How are you all doing this morning?
Good, how are you?
Doing great. Does anybody have any questions for the upcoming test review or regarding the layout of the exam or anything like that?
Yes, sir. I had a question.
Okay.
It has to do with homework 6, which is nodal analysis.
All right, let me pull up homework 6 real quick. Alrighty, which problem?
Number 5.
Number 5. All right. That's not what I'm supposed to be sharing. Homework 6, number 5. Alrighty, so what is your question?
So, I'm fairly on each part of it. I know you're supposed to get the note. I did everything. The only part I'm having issues with is developing the power equation at the end. That's the part I'm still confused on.
Okay, so if you've done all of the previous nodal analysis correctly, it says use nodal analysis to find the power supplied by the 4ix dependent source. So I'm going to label a current. And I'm going to call it I dependent, okay? And we know that the power supplied by the dependent source is going to be the voltage drop over the dependent source, which is 4ix multiplied by the current flowing into the negative polarity terminal, which is the current that I've labeled as I dependent, right?
Yes.
So the question then becomes, how do we express I dependent in terms of things that we know? Well, I would argue that if we apply Kirchhoff's current law at this node, I dependent will simply equal this current plus this current.
Okay.
So for the sake of argument, let's call this VA, VB, VC. This would be 4ix. So Ix would be VC minus whatever V1 is divided by 5 ohms times the sum of I1 plus VB minus VC divided by 20 ohms. And I should be clear here. I'm considering the bottom node as my reference. Seem reasonable?
Yes, sir.
All right. Any other questions regarding any homework assignment or any of the practice exams?
For homework 8, number 5, I believe.
Homework 8, number 5. All right.
I got everything correct. The first thing I saw for was the voltage, and then I used that voltage to find everything else, I believe. But when I typed all my answers in, it said that the voltage was wrong, but everything else was correct.
All right. So in the circuit below, you're given a bunch of different resistor values, and you want to use source transformation and resistance combinations to simplify the network until only 2 elements remain. So I have a slight issue with how this circuit is drawn, just because it's, to me, not super clear exactly what it is that you're supposed to do. So let me draw the circuit real quick. All right, so this is R1, R2, IS, R3, R4, R5. So what I don't like about how this circuit is drawn is because it's not specified that these are the open circuit terminals that you're effectively trying to simplify everything to.
Mm-hmm.
So looking in through those open circuit terminals, you're asked effectively to either generate a Thevenin equivalent circuit or a Norton equivalent circuit. And so, well, let me rephrase that because this is homework 8 and you haven't learned Thevenin Norton equivalent. A practical voltage source or a practical current source, which is the same thing as a Thevenin and Norton equivalent circuit. So, do you want to use, so we're going to have to actually put in values, I guess, if we're going to go with this guy. So
Yes, sir.
R1 and R2 for me are 17.5 ohms. R3 and R4 are 5.5 ohms. And R5 is an 11 ohm resistor. And finally, IS is a 3.5 amp source. All right, so we can see right off the bat, or hopefully we can see right off the bat, that R1 and R2 are simply connected in parallel. So we could combine them. Based on my values, that would be 17.5 over 2, which is 8.75 ohms. So I guess I'll draw it out multiple times. So we would have an 8.75 ohm resistor here, 3.5 amp source here, 5.5 ohms, 0.5 ohms, 11 here in the terminal. All right, so what would our next step be?
I put the current source to a practical voltage source, combined it with that 5.3 ohm.
Okay, sorry. All right, so converting the practical current source into a practical voltage source, that seems good to me. So let's see. So I'm going to have a voltage direction, positive polarity on bottom because my current arrow is directed down. 8.75 times 3.5. Gosh, I don't think I can do that in my head. Can somebody with a calculator help me out real quick?
30.625.
All right. And we're going to have an 8.75 ohm resistor in series with a 5.5 ohm, 5.5, 11. There we go. So we could easily see that the 8.75 ohm resistor and the 5.5 ohm resistor are in parallel. So that's going to be, I think, or excuse me, in series. So that's going to be 14.25. Once I combine them. That eraser thing will work. So what would I do next?
Transform it back into a practical current, and then that's in parallel with the 5.5.
That is correct. So we're going to have a current source direction down. That is 30. That's not remotely a 3. 30.625 volts divided by 14.25 ohms, whatever that is. And I'm just going to leave it like that for now. In parallel with 14.25, in parallel with 5.5, now we have 11. And so now we can combine the two parallel resistors, correct?
Yes, sir.
All right, so 14.25 in parallel with 5.5 is going to be something I can't do in my head.
3.97.
3.97, thank you. And then our last step would be, oops, scrolled too far, guess I'm running out of room here, to do one final source transformation here.
Mhm.
So,
Well, yeah, that's the thing is that I did exactly that, and I got the equivalent resistance right, or not equivalent resistance, but the final resistance value correct. And then when I transformed it back into a practical current source, I got that current correct. But the voltage wasn't correct. And you should be able to multiply that current by that resistance and get that voltage, but whenever I type that in, it just isn't correct.
so do me and change the sign on your voltage.
Yeah, I tried that.
Okay. Because
But it's just interesting to me because I solved for the voltage first, and then that's the thing that's incorrect.
yeah, I'll have to look in. So let's see. Let me go to student progress then. What's your name?
Braden Ferguson.
Ferguson. All right. And this is homework 8. Oh my gosh, my dogs are jerks. Problem 5.
Yes, sir.
What it's looking like to me, based on what the correct answer is and what your answer is, you need to change the sign, and you have a little bit of excessive rounding error because you're literally 50 millivolts off of the correct answer. So you did everything perfectly correctly. It's just there was too much rounding.
Okay, that makes sense.
All right, so sorry for wasting 10 minutes on a problem that you did correctly.
That's fine.
All right, any other questions?
Yes, on the practice test.
Fall or winter?
This will be the fall one.
All righty. Which problem, sir?
It's not really like a circuit one. It's number 10.
Okay.
It's just a word problem.
Yeah, all right. So number 10 says that a 48 volt battery, so I'm going to write down V is equal to 48 volts, is connected to a resistive network for a duration. So I'm going to say T is my time of 5.295 seconds. If a power of 6.843 watts, so power is going to be 6.843 watts, is supplied to the battery, the equivalent resistance of the resistive network is closest to something. So we have voltage, power, and time, and we are trying to figure out the resistance value R. So for a known resistance, power can be expressed as V squared over R or I squared times R. We're going to use this guy, and so we're going to have R is equal to V squared divided by P. And there we go. The time was just there to confuse you.
Cool. Also, the next problem, it's kind of like a concept problem as well. It's not really, well, I mean, I guess it could be looked at as a circuit problem, but it's,
Problem 11.
yes.
Alrighty. So let me draw this guy out here. So we have, let me zoom in so I can see better. I'm getting old. All right, so we have a 15 volt source. We have a generic circuit element A. We have a dependent source twice VC. We have an element B in series with an element C. And then out here we have an element D. I have a source here. It's 5 volts. We are told, let's see, here's VD, ID, C, C, B, A. All right, so I think I copied all that stuff down correctly. Let me double check. IA is from left to right. VB positive polarity on top. VC positive polarity on top. VD positive polarity on top. IC is down. ID is up. All that seems legit. We're told VB is equal to 10 volts. VD is equal to negative 17 volts. IA is equal to 7 amps. And IC is equal to 5 amps. ID is equal to negative 2 amps. We want the power absorbed by the dependent source. So that means I want to figure out what this current is. I'm going to call it I dependent. Okay. So I would say then that I'm going to have to do KCL at this node to figure out what that current is. However, that will also require me to know this current, and I'm going to have to do KCL at this node. So let's call this guy node 2, and this guy node 1. All right, so KCL at node 2. I'm going to have, I need to give this a label, I guess. So I 5 volts. So I 5 volts is leaving. Our current IC is leaving, and our current ID is entering. So we can write this equation where we're assuming that currents that are exiting are positive and currents that are entering are leaving. Since the only thing that we don't know is that I 5 volts, we can rearrange this to be I 5 volts is equal to ID minus IC, which is -2 amps minus +5 amps, gives me -7 amps. Hold on, I need to go tell my dog to stop barking at my lawn guy. Alrighty, from here, we can apply Kirchhoff's current law at node 1, and we would see that all 3 are entering. So I'm going to kind of skip a step here and say that I dependent is equal to negative IA plus I 5 volts. Is everybody okay with that?
Yes.
All right, so that's going to be -7 amps plus, let's see, IA is +7 amps. So that means I dependent is 0 amps. So if there's no current flowing through our dependent source, the power absorbed has to be 0 watts. So we don't even need to figure out what the voltage VC is.
Can you explain the currents entering are going to be negative or positive?
It is your choice.
Okay.
So if the currents, if I have assumed the convention that currents that are leaving the node are positive and currents that entering the node are negative, but it is entirely up to you. As long as you're consistent, it literally doesn't matter which way you do. Just currents that are in the opposite direction effectively should have an opposite sign is all that matters. Sound good?
Yes, thank you for that, answering that problem.
Any other questions?
Yes, sir. If you don't mind, on the fall 2019,
Okay.
number 20,
Number
or
20.
22.
20 or 22 or both?
Just the general logistics of how you solve for the 31 volt source, like it says how it contributes.
Sure. All right, so for problem 20 and 21, when I'm asking for the contribution of a particular source, that is me telling you to do superposition. So for problem 20, the contribution of the 31 volt source means that we will leave the 31 volt source on and turn off the 2 current sources. So let's see, we're going to have our 31 volt source on. R is 13 ohms, so I'm just going to write 13 ohms here. We're trying to find Vx prime, and let's see, that's going to be a short, that's going to be a short. So we could have something here, like the open circuits where the current sources are as well, or we could just not draw a line there. Either way is fine. All right, so this is a properly redrawn circuit for determining the contribution of the 31 volt source. So I'm going to ask you guys how you could solve for that voltage Vx. Anybody have any suggestions?
You can use voltage division.
Use voltage division. I was hoping somebody would say that because that is the absolute easiest way to go about this problem. So let me explain, for those of you who voltage division doesn't jump out at them, why we can use voltage division. We know that 31 volts is the potential difference between this point in the circuit and this node down here, regardless of what path we take. So what this really looks like, if we draw it maybe in a slightly less weird way, is that we have a 31 volt source, and then on one path we have a 15 ohm resistor and a 7 ohm resistor, and on another path we have a 13, an 18, and a 6 ohm resistor, and we want the voltage drop over the 13 ohm resistor. So these two circuits are identical. So using voltage division, we would have 31 volts times 13 ohms divided by 13 plus 18 plus 6 gives us, I'm assuming, 10.892 volts if I did my math correct. Okay, so anytime I ask for the contribution of a particular source to a quantity, that is my way of telling you apply the superposition principle and turn off every source but the one I tell you to specifically. Any other questions on 20 or effectively 21, since it's a very similar thing? Contribution of the 4 amp source means you leave the 4 amp source on. Turn off the 31 volt source, so that would be replace it with a short circuit, and turn off the 2 amp source, so that would be replace that with a open circuit.
What method would you use to solve that problem?
Let's take a look at it and see.
Dr. Hartman, if you don't mind, if you did mesh right there, once you redrew the circuit into the two loops, you could find the current going through that leg of the 13, 18, and 6 ohm resistor, and then you could find the voltage drop that way.
Yeah, 13 ohms times that mesh current I2, sure. But there's nothing wrong with that solution. It's just far less efficient. So students tend to try to rely on mesh analysis foremost, and then maybe to a slightly lesser extent nodal analysis. And then if for whatever reason those two things can't work for you, which there's very limited cases where they can't work, then you guys go back to the fundamentals. And in a problem like this, you know, where just by visual inspection you could see that you could use voltage division and get the answer in one step, my question would be, why would you want to set up a system of equations and then do something else? Nothing wrong with it, it's just going to take you a lot more time, but it's your test. All right, problem 21. So contribution of the 4 amp source. So my 31 volts is off. 15, 7, 4 amp, 6 ohm, 18 ohm, 13 ohm, VX double prime. Positive polarity on the left, negative polarity on the right. All right. So I'm trying to think of the most efficient way to do this. And I'm wondering if combining the 15 ohm resistor and the 7 ohm resistor, because they are in parallel, will be of any benefit to me. Sure, let's see. All right, so 15 times 7 over 15 divided by 7 is going to be 105 over 22. Can somebody double check my mental math there, please?
Yes, it's 105 divided by 22.
All right, so that is what it is, but I don't know that it actually helped. I was thinking I could potentially do current division here, but I don't know that that is going to work. So I have 1. Maybe mesh. So I was thinking about nodal analysis, where I would consider this guy to be my ground. So this whole thing is ground. And then that would give me 1 node, 2 nodes, and 3 nodes. But if I do mesh analysis, then I just have 2 simple loops now. And I think that's a little bit easier. So I know that I2 minus I1 is going to be 4 amps. I know that, let's see, if I start here and go clockwise around this loop, I'm going to have 13 plus 18, so let's call it 31 ohms times I1 plus 6 ohms times I2 is equal to 0. And that should be pretty easy to solve. We might actually be able to do that using substitution or something. But anyway, so we can solve that for I1 and I2, and then VX double prime would be negative 13 ohms times I1. Oh, wait. Positive 13 ohms times I1. Any questions on my application of mesh analysis here? Any questions, comments, or concerns? I am off-put by your silence.
Wait, so you said to multiply by negative 13 ohms?
Originally I said negative, but that is wrong because the current I1 is flowing into the positive polarity terminal when it goes through that top path. So it should be positive 13 I1.
Well, when I multiply it by positive 13, that gives me the positive version of the answer rather than the negative.
So I have I1 is flowing in around its clockwise loop. It's flowing into the positive polarity terminal. So did I make a sign error somewhere else? All right, so let's see. I2 is in the same direction as the 4 amp source. I1 is in the opposite direction of the 4 amp source. So this guy seems correct. Then I have 13 ohms. So starting here, I have a short circuit, 13 plus 18 is 31 multiplied by I1 plus 6 multiplied by I2 is equal to 0. So that's right. So there is a distinct possibility then that I should have a positive sign on it instead of a negative sign then. So I made a dumb mistake when I solved this originally because I don't see any error with how I'm doing it right now. Then again, I didn't see any error with how I was doing it then, so we'll see. Yeah, the current I1 is flowing into the positive polarity terminal, so it should be positive 13 times I1.
Can we do the number 23 set?
Sure. Give me just a second. I want to look at my solution for 21 there and see if...
I see what I did wrong. In that first equation, I swapped up the 1 and the negative 1. That's all.
Okay, great. Okay, so I didn't make a mistake. All right, I make them all the time, so it wouldn't be a big surprise to me. But yeah, I thought I had gone through all these solutions pretty well to make sure that there were a minimal, or hopefully no boneheaded mistakes. But anyway, all right. Let's see. So you said number 23, correct?
Yes.
All right. I think there might be enough room to sneak it in here. So we have a current source. IS is 9 amps.
What problem is this again?
23 on the fall.
Awesome. Okay, thank you.
Sorry, that looks too much like a 12. It's supposed to be 17. All right, we want dx for 23 and IY for 24. Okay, let me see here. I'm going to choose to use Nodal Analysis. I'm going to put my reference node here. This whole top node will be node A. This guy will be node B. This guy will be node C. So I will have my KCL at node A equation. I'm going to have -9 amps plus VA minus VB over 20 plus VA minus VB over 8 plus VA, come on, pen thing, minus VC over 6 is equal to 0. My KCL at node B. Let's see. VB minus VA over 20 ohms plus VB minus VA over 8 ohms plus, what's going on with my hand here? VB over 5 ohms plus VB over 17 ohms is equal to 0. And finally, KCL at node C. Hold on just a second. I'm going to have VC minus VA over 6 plus VC over 19 is equal to 0. Solve those guys, and then VC is exactly equal to VX, and IY is VB over 17 ohms. So that's my gut reaction on how to solve this problem.
Could you explain the fundamentals of nodal analysis? Like how are you able to select the VA, VB, VC, and is that the only way you could select those nodes?
No, I could put my ground anywhere. I just chose to put my reference at the bottom. So nodal analysis tells us the potential difference between our node of interest and our reference node. So VA is a shorthand notation effectively for the voltage drop over this 9 amp source. VB is a shorthand notation for the voltage drop over our 5 ohm resistor or our 17 ohm resistor, because those two guys are in parallel. It doesn't matter where I choose to put my reference. In this problem, everywhere was equally as easy. So if you review the nodal analysis lecture, that would be lecture 6, I believe. My first step is to choose a reference node, and I usually choose a reference node where the most things are connected. So in this case, the bottom node is connected to the 9 amp source, the 5 ohm resistor, the 17 ohm resistor, or the 19 ohm resistor. So it's got 4 things connected to it. The top node also has 4 things connected to it. The middle node that I've assigned VB also has 4 nodes connected to it, where the node VC only has 2 things connected to it. So really the top, middle, or bottom are all good candidates to choose as our reference node. I chose the bottom just because that's kind of my default setting. I'm applying Kirchhoff's current law at all of the non-reference nodes. And so, for instance, my KCL equation for node A, I am adding together the following currents. This current directed to the left, this current directed diagonally down and to the right, this current directed diagonally down and to the left, and this current directed to the right, because those are all 4 of the branching currents that are leaving node A. And I chose those particular directions, the ones I've outlined in green, because they will give me positive values, or a positive sign everywhere I see VA, the nodal voltage associated with node A, and minus signs whenever I see any other nodal voltage. And then I just applied that principle throughout the whole thing. Now, there is a way that we could do this problem using mesh analysis for those of you who probably are most of you that are more comfortable without really losing any necessary information. Would you care to hear how to do that?
Yes.
All right, so I'm going to delete all these node things. So right now, the reason why I would be hesitant to do mesh analysis is because there are 4 meshes, right?
Yes.
Unless you have one specific calculator, you can't do that. So how are the 20 ohm resistor and the 8 ohm resistor connected, electrically connected?
Parallel.
Yeah.
So what's 20 in parallel with 8?
160 over 28.
All right.
Couldn't you just make the far left, I guess, mesh loop I1, and then that becomes 9 amps going around that loop?
You could. That's fair. 160 over 28. So what that gentleman was suggesting was if this is I1 and you know what I1 is, you would have had 3 equations, 3 unknowns anyway. But what I've done is split it now into 3 meshes where one of them is known, so it's even easier. Just by making a simple resistance combination. So that I didn't change anything that's associated with the current IY, and I didn't change anything that's associated with the voltage VX, so we could do mesh from here and get both of those values pretty easily, where VX in this case would be 19 times my mesh current I2, and the current IY would be I3 minus I2. That being said, mesh analysis is great and all, but there are some circuits that we're going to be dealing with in this class where nodal analysis is effectively the only way that we're going to be able to solve them. So I would familiarize myself with nodal analysis sooner rather than later.
Thanks for that tip.
Yep, no problem. Any other questions on anything? Anybody, any questions?
You're using the TI-36, correct?
I have a TI-36X and a Casio FX115, although neither of them are with me, but yeah.
Okay, well, I just got the TI-36, and I've never used a calculator where I do a system of equations to solve for that. I mean, I can just figure that out on my own, but...
So what I would do, so let's see, I'm going to have to do this from memory effectively. I'm trying to remember where the system solve button is. I believe it might be no, it's not the tangent button, but it's somewhere close to the tangent.
You're right. No, it's right. It's on the tangent button.
Okay, so second tangent, I guess, and then hit number 2 for the 3x3 system solver or whatever.
Okay.
So my coefficients, let's use my nodal analysis equations, okay? So my coefficients for VA in the first equation are 1 divided by 20 plus 1 over 8 plus 1 over 6. And you can literally put it in just like that. So 1 over 20 plus 1 over 8 plus 1 over 6. My coefficients for VB are negative 1 over 20 plus negative 1 over 8.
Okay. Okay, I see that.
And my coefficient for VC is just negative 1 over 6.
What kind of Casio did you say you have?
I have an FX 115, but that's the one I use way less often. So I couldn't, off the top of my head, tell you how to use the system solver. Give me just a second. Oh, so there's an emulator for Casio FX calculators that you can get on your computer, but I'm not paying $25 for an emulator of a calculator that only cost me $12. Sorry. If you're unsure of how to use your Casio calculators to solve the system's equations, I'm sure there's a ton of YouTube videos and all that kind of good stuff that you could go to. But it's effectively the same process. All these fancy calculators nowadays, we don't even actually have to simplify the equations really. So like what I was suggesting, the gentleman that was asking about this thing to do is instead of figuring out what the lowest common denominator is and multiplying through and all that kind of junk. Sorry, my lawn guy is apparently doing something right outside my office window. I always just put in the fractions, right? So I can see that for VA, I have a coefficient of 1 over 20 plus 1 over 8 plus 1 over 6 in this first equation. For VB, I do the same thing. I have negative 1 over 20, negative 1 over 8, and then for VC, I have negative 1 over 6. My constant term is 9 when I move that over. So I don't ever simplify fractions or anything like that. I literally just look at these raw equations and then effectively put them in my calculator as best I can and hit enter.
How exactly would you, because it has like a 4x3 matrix.
So the fourth thing, all right, so how it's set up, and it doesn't matter whether you're in the Casio equation solver or the TI equation solver. It is, you're exactly right that it is a 4x3 matrix effectively. Okay. No. So it might look something like this. All right. So I'm going to call this guy X1, X2, X3, and C. So let's say that we have a 3x3 system of equations where we might have, let's call this A1, X1 plus B, hold on, this needs to be D then. B1, X2 plus C1, X3 is equal to D1. A2, X1 plus B2, X2 plus C2, X3 is equal to B2. And A3, X1 plus B3, X2 plus C3, X3 is equal to D3. So X1, X2, and X3 are our variables. Excuse me. A, B, and C are our coefficients in our equations, and D are the constant values that are moved to the other side of the equal sign. So you would put into your calculator A1, A2, and A3, B1, B2, and B3, C1, C2, and C3, D1, D2, and D3. So for our example, A1 is -1 over 20 plus, positive 1 over 20, positive 1 over 8, and positive 1 over 6. 1 over 20 plus 1 over 8 plus 1 over 6. B1 is -1/20 minus 1/8. C1 is -1/6, and D1 is 9. And this is all of the information from equation 1. In equation 2, our coefficient for our first variable, or my first variable I'm saying is VA, I'm going to have -1/20 and -1/8. So A2 is -1 over 20 minus 1 over 8. My coefficient for VB is positive 1/20, positive 1/8, positive 1/5, positive 1/17. My coefficient for C2, so that is what's corresponding with VC. There isn't a VC in my equation, so that's going to be 0. And similarly, if I look at this equation, it's equal to 0. There is no constant value term, so D2 is 0. For my third equation, that might not be enough room. A3, the coefficient associated with VA is -1/6. B3, coefficient associated with VB is 0, if I'm not mistaken. Yep. C3, the coefficient associated with VC is 1/6 plus 1/19. And D3 is equal to 0 because there's no constant value terms. So these are all the things that I would put into the little matrix that my calculator has. And then I hit enter and it solves it, and it spits out the values for the variable X1, which in this case would be VA, the variable X2, which in this case would be VB, and the variable X3, which in this case would be VC. And depending on your calculator, it may store those variables as X, Y, and Z, or some other things. Just depends on which calculator you have. But the basics are all are common to both the Casios and the TIs.
Yes, I see it now. Thank you very much.
Yep.
Yes, thank you. I've been struggling with this whole thing with my calculator for a long time.
Oh, no problem. Hopefully that helps. And YouTube and practice and all that kind of good stuff. You got a couple of days to figure it out. If you need any more help, contact me directly. I'm going to be going into my office tomorrow, so I will actually have access to my calculators and stuff, so I won't have to do things from memory, and we can talk our way through things. All right, any other questions on any of this stuff?
Yes, sir. Well, I just had a question about Thursday. Are you possibly going to be free during class time like we normally do right now? Thursday for some last minute questions or no?
Yes, I was not intending on holding a full-scale Zoom meeting or anything like that. That's what this review session is for, but I'll be free later on today, tomorrow, and Thursday via email and all that kind of good stuff. If I need to hold the Zoom meeting, I guess I can, but I'm not enthused about the prospect. Let's put it that way.
Yes, sir. Gotcha. Thank you.
Any other questions? All right. Well, unless any of you guys need to reach out and contact me before the exam, I will. You will not see my pretty face, I guess, until next Monday. But the test is Thursday evening at 6 p.m. It will be on Moodle using the Respondus lockdown browser, which, again, I've said it at least 3 times at this point, but does require that you have a webcam. So if you don't have one yet, go get one, or you cannot take the test, and therefore you cannot pass my class. All right, catch you guys later.